Hello, it's Chase Blau with Team 44 here to do an update on our design project. We are currently in phase 2. Our mission statement is to provide an affordable RC car with lap counting and lap functionality. Our customer needs are here on the left, with the most prioritized on the top, with price, durability, and maneuverability leading those. Our specifications are in the parentheses right next to it. Our use case for this product is for someone, the consumer, to go out and design their own track or create a replica of an F1 track or NASCAR track if they enjoy those things. And they can race against friends who also have RC cars, or just challenge their own times over and over and try to beat them. Our customer profile is a male engineering student who enjoys technology and wants to take on the challenge of creating and assembling his own RC car, and preferably has access to a 3D printer. Our functional decomposition was us looking at what minor and major functions our RC car had to complete. So the major functions are on the right, and that includes steering, accelerating, and counting the laps and the lap times. Our minor functions were to store and provide power, accept and transmit user input, and sense the finish line. So to complete these tasks, we knew we needed some form of transmitter and receiver, a controller, which is the ESC, 2 motors of some form. Here we have a servo and just a regular DC motor, and as well as an optical sensor. So using that base of ideas on what we needed to complete these functions, we created a concept table, and in the beginning we used industry standards of what other companies were using to build their RC cars and develop them. And that's where some of the more general ideas come from, such as rubber tires, rechargeable batteries, gearing and belt systems for the power transmission. And from here we got a majority of our ideas, but when we performed the 4-2-1 method, that is where our creative side came out, and we got some more original ideas going. Such as using a control lab, contact charging solar panels. So through the 4-2-1 method, we came up with a bunch of new creative ideas that we knew we wanted to at least attempt to implement into some of our concepts. So each member created their own concept selection on this table and took those designs and created sketches, which became our gallery method. So for our gallery method, we each designed our own sketches that outlined the selections we made. And then we performed CAD models for each of these, and then we discussed them as a group, talked about what we liked best on each design and which we felt wouldn't work on each design. And through discussion, we found that Ty's design was probably the most feasible of all of them. So from there, we took that design and created a prototype, which we presented to Team 43 for our feedback session. Team 43's main concern was us using 3D printing instead of an injection molding or other form of production. We wanted to use the 3D printing because our original idea was to either offer this as a kit where the consumer could 3D print the assembly and assemble it themselves, or just outright buy the RC car. So because of this concern, Team 43 felt it would be possible for someone who downloaded the CAD to accidentally mess up on the print or not use the right filament or any form of user error. So we decided to combat that. We had to add looser tolerances as well as some adjustability in our design, so things didn't have to be completely rigid and could work with some leeway. Additionally, we completed a failure mode analysis, in which we had concerns about the motor overheating, wires getting pinched, the battery getting damaged, as well as the chassis not being durable enough for our standards. So to combat these, we added an ESC controller that would have a thermal cutoff. And additionally, if we felt it needed in the future, we could design for a heat sink or a fan. For the wires, we decided to add securement points to our chassis for zip ties to secure the wires to it, as well as make sure that all the wires could be routed free from any pinch points and moving parts. For our chassis durability, we went ahead and designed some braces for the front and rear. And this is just to give the chassis a little bit more of a stiffer feel, as well as stiffen up the steering some, and overall just increase durability and maneuverability. And then finally, our battery, we decided to use a hard case rechargeable battery and enclose that within a shielding that you'll see later in the final design. So we performed the concept screening, in which we eliminated my design due to feeling it was a little too cost heavy due to all the Bluetooth capabilities. And while it offered the best range, we felt that considering price was the most important customer need, that not to continue with any of my design. And the same thing kind of applies for Grayson's. And we were concerned that the rechargeable batteries could be a cost issue over the long term and might dissuade some of our potential customers, as well as may have some runtime issues. Greg's design we considered keeping due to his unique steering, which implemented a motor and like a rack and pinion type of design that we all thought was pretty interesting and could be unique. But overall, it just later on we decided it wasn't going to be feasible for this scale of project. And so we are going with Kai's design and implementing some of our ideas into this design. We came up with two-stage gearing in the differential, using a tab and slot design instead of traditional fasteners such as screws and nuts and bolts and such, which will limit the costs because you won't have to buy as many screws and fasteners and such. We're additionally going to laser cut the parts out of acrylic or potentially like plywood, which will also stiffen up the chassis, we think. We're going to focus on using some of the existing parts we have just for the prototyping to make it easier. We're going to include dual optical sensors in our design, and these are the braces I was talking about in this design we have right here. The brace is built into the battery case, and the rear brace is shown right there. Additionally, we may or may not add a bumper, rear and front bumper to this design, but overall this is about what our final design is going to look like. Thank you.